Firstly, you need to add your protective sleeve to the fibre. I'm using a 40mm sleeve, but they do come in a variety of lengths. Remember, you need to put the sleeve on at the very start. Otherwise, at the very end, you're going to be kicking yourself when you realise you need to do it all over again. Next, you need to strip off all the protection so you have just the bare fibre. Different cables have different sized cores, claddings, coatings, buffers, strength members, outer jackets, and a variety of different names to refer to all of these things. So you need to know what type of fibre you're working with. Here are some examples. All of these have an identical 9 micron core but a variety of outer jacket sizes. From right to left we have 3mm outer jacket, 2mm outer jacket, 900 microns and a bare fibre. For this demonstration we're going to be using two 900 micron fibres. So here are the strippers I'm going to use. As you can see, there are different size grooves on these strippers which can remove different layers of the plastic coating and are suitable for a range of fibre sizes. The best advice when stripping a fibre is to nibble away at the protective coating and remove it in small layers and sections. There are several different layers which you can see as you start to strip them away. You want to aim to strip off about 30mm of coating on both fibres for a good fusion splice. If you clamp too hard or try and remove too much in one go, you're very likely to just snap it like so. And here we have it. This is what a bare fibre looks like. If you run it through the strippers, then there should be zero resistance. It's always worth double checking. Once you have stripped away all the protective layers, the next step is to clean the fibre. Hopefully you've already watched our video on the importance of cleaning fibres and the different tools out there to do this. Here we are using IPA wipes. You should hear the squeak when it's clean. Once clean, refrain from touching or putting the fibre in contact with any dirt. A dirty end will affect decibel loss and make the splice less effective. As we mentioned earlier, the cleave is the most important part of the whole process. We are trying to get a perfectly straight cut to allow the two fibre cores to make maximum contact with each other when they are fused together. First, place the fibre into the appropriate V-groove as indicated on the cleaver and flip down the magnetic panel to hold it firmly in place. You want to make sure that the bare fibre is sitting over the far left rubber pad as you can see here. By doing this, the cut end of the fibre will be swept straight into the bin. Should this not happen, you must remove the cut end from the machine manually using tweezers or sticky tape and place it in a sharp spin. Once the fibre is held in position, in one smooth motion close the lid of the cleaver and press down the cleaver button like so. When you open the lid, you will see the cleaved fibre. Lift the magnetic panel and carefully remove the cleaved fibre from the cleaver. Remember, from this point on you do not want it to be touching anything, as this may damage or dirty the clean cut you just made. Make sure your fusion splicer is powered on by pressing the red button and that all the settings are correct for your chosen fibre type. This can be changed like so. Lift up the dust weather guard and wait as the machine makes its automatic adjustments. Lift up the magnetic flap and place your cleaved fibre into the V-groove, making sure that the tip of the fibre does not cross over the electrode. Placing the fibre can be trickier than it looks, as it has a natural curve to it, but persist. Flip down the magnetic flap to hold the fibre in place once you are happy. At this point, start the whole process over again with the second fibre and load this into the other side of the splicer. Once both are in place, close the dust weather guard. The fusion splicer will move the fibres in towards each other and an image of the two fibre tips will be displayed onto the screen for you to examine. This is your chance to make sure your cleaves are neat and clean. If your fibres are positioned too far from the electrodes, then an image will not show on the screen for that fibre. If either fibre tip crosses the electrode, then an error message will appear. If you're happy with your cleaves, then press the green button. You will hear a beep and this will start the splice process. The fusion splicer will line up the cores of the fibre to join them together and do a quick automatic pre-clean of the fibres to blow away any dust residue before it begins the actual splice. It will also report any errors if it cannot perform the splice. Your fibres have now been spliced together. The screen will display either a green, amber or red light to signify whether the splice is good, okay or poor, as well as showing an estimated dB loss. For a green light and a perfect splice, you would have a 0 dB loss, but ideally no more than 0.2 dB for it to be successful. If you get an amber light, common reasons for this are that one or both of the fibres were dirty, that the cleaves were not straight enough, or that there is a mismatch in the core dimensions of the fibres. Here are some pictures of some of these errors. Here we can see examples of good cleaves, bad cleaves, which could be due to dirt and dust or the fact that the cut is not straight, and some fibres that are not cleaved at all. Make sure you do not open the cover until the splice is complete and the machine has beeped. Lift the lid but wait a few seconds as the fusion splicer will be completing a tension test on the fibre. Carefully we remove the fibre. At this point we do not wish to bend or pull on the fibre as it could snap and undo everything we have just done. Gently slide the protective sleeve over the splice. Make sure you have an even amount of clad fibre on both sides to ensure there is an equal amount of strength on either side of the splice. Lift up the lid on the heater element and carefully place the splice with its protection sleeve into the heater, ensuring it is in the center of the heater element. Close the lid, making sure you do not get the fibre caught underneath the two metal latches on the side, as when you push them down they could snap the fibre. If you haven't already, make sure you've closed the magnetic flaps and the dust weather guard down again to keep the fusion splicer clean. The machine will automatically start to heat the plastic. You will know it's working as the light next to the yellow heater indicator shines red and the heater symbol in the top right of the screen shows you the progress. You are able to change the heat settings depending on the thickness of the protective sleeve you are using. It's worth checking you are on the right setting before you start, as you may burn your sleeve. When complete, wait 15 to 20 seconds for the glue to harden, then remove the splice using caution as it could still be very hot. And there you have it, a completed fusion splice. There should be no bubbles inside the protective sleeve, which would indicate overheating, or no upturned ends on the protective sleeve, which would indicate not enough heat. You should be able to see a small amount of glue coming out from each end. Perfection. In the real world, splices need to be kept in protective cases, conveniently called splice trays, which are then placed inside a splice closure. You can see some examples of splice trays here with their lids open or removed, including one known as the bomb in the center of the bottom row. The splice tray protects the splices from moisture and ensures they are not being put under any unnecessary pressure or tension. Some patch panels have splice trays built into them to simplify storage.